G'day guys, how you going? I'm going to go through the next part on the normal distribution stuff. In your textbook you'll find a lot of information about z-scores. The z-score is pretty simple. It's just, all it is the value. What you do is you take away the mean from that and then you divide it by the standard deviation. Now the standard deviation, remember, is how far it varies from the mean, and remember within one standard deviation we have about 68% of the population, two standard deviations about 95%, and then three standard deviations 99% of our population falls within three standard deviations. So x bar is in fact our mean value, and our standard deviation is in fact the bit over here as well. Alright, that's our S value. So just an example very quickly for that. If we had our x bar is equal to 50 and our S is equal to, say, 10, then if we did a value of an x score of 50, then what you're going to have over here, it's your z score. That's what we call it, a z score. That's going to be equal to 50 take 50 all over 10. Now 50 take 50 is 0, so therefore that's going to relate to this point here. So that's saying that 50 is in fact the mean value of our data. Now let's try another value. If I had x is equal to, say, 40, right, so then that will become equal to 50 take 40 all over 10. That gives me 10 over 10, which would be 1. So that's saying this value over here, one standard deviation or one from away from the mean, we've got a z-score of 1. Alright, so if we went two standard deviations, so in other words, if x was equal to 30, then that would become 50 take 30 over 10, which would become 20 over 10, which is 2. So then we'd be two standard deviations away from here and three standard deviations. So really, the number of standard deviations that you are away from the mean is in fact your z-score. Alright, so this particular axis here tells you your z-score. Now the good thing about this, if we use a z-score, remember the previous section we did, we only looked at a value having to be 1, 2 or 3. If we use our z-score, we can have a z-score of 1.2 or 1.5 or 7 or 2.6 or minus. Okay, so keeping in mind these z-scores here are actually minus ones, and these z-scores over this way are going to be 1. So we'll have our z-scores going between 1 and -3 and 3, roughly about -3.3 to 3.3. Alright, so that's all your z-score stuff. Now that was really useful if you didn't have a graphics calculator that didn't have a way of working it out. But we've got graphics calculators that allow us to actually work this information out anyway. So I'm going to show you a really simple way of doing this on your calculator. And you know, we can talk about z-score stuff as well, but the setting out of these questions, once you get the idea of what you're doing, is really simple, and you do it on your calculator, and that's what we're expecting you to do. Alright, so the mean length of a sample nail is 25.3 and the standard deviation is 0.4. So that's what you need to about identifying here. This information in the question are the key information. Alright, so we're working in millimetres, so we want to work out the probability that's going to be greater than 25. Right, so first of all we need to look at the formula that you need to use, and I'll go through that first of all. So the thing is, we've got on our calculator we've got a thing called the normal. Right, we've got a PDF. Right, and then we've also got a normal CDF. Right, so this one stands for when you're looking for only one value, and this is working out if you need to look at a range of values. Alright, so that's what we use. This one's got a cumulative distribution. This one's just for basically a set value. Alright, so if we were looking at a diagram here, then if I was looking for what the chances of me getting a value, then that would be my PDF. If I was looking for a range of values, say like in here, then I'd be using my CDF. Alright, so that's what we will look at. Most of the ones that we'll be probably looking at are the CDF ones, so that's where you'll probably use most of your efforts. Alright, so I'm showing how to do that on the calculator. What you basically doing in your thing, so this is the way it's set up. It's the normal CDF. Then what you have is you put in your lower value. Let's go lower value, you put in your upper value, you put in your mean value, and then you put in your standard deviation. Right, that's what we need. Now, if we don't have a value for lower or upper, then we use minus e to the 99 for that, and then we use e to the 99 for that. Alright, so I'll show you how to do it on the calculator when we do the question. So the first question that we've got there is we've got a nail, and we know that the mean length of a nail is 25.3, so you should write that down. So the mean length of the nail is in fact 25.3 millimeters, and we know that the standard deviation is 0.4 millimeters. So the first part of this question is asking us, what's the chances that we're getting at a nail that's greater than 25? So that's how we set that out. So the probability for A of X being greater than 25. Now, if I was looking at my Z-score would be, obviously looking at that value, that would be 25, take 25.3 all over 0.4. Okay, so if I just did that on my calculator, I'll just quit out of there. So 25, take 25.3, enter, and then we divide that by 0.4. That's telling my Z-score of negative 0.75. So that's negative 0.75. So when we're thinking about our distribution, right, there's my mean value. We're looking at a value being something like that, negative 0.75. Right, so that's the area that I'm actually trying to calculate, being greater than there. Right, so you don't have to do what I'm just talking about. I'm just going, showing you a little bit more than you need to. What I'd be expecting you to do is this. I'd like you to write this as normal CDF. My lower value is in fact what? My lower value is 25. My upper value, I don't have one. That's going to be e to the 99. Then my mean value is 25.3, and then my standard deviation is 0.4. So this is where I'm going to go to my calculator and show you how to do this. So just follow, and I'll make sure this is on big screen so you can see it. So there's a button above the bars button called distribution. So we go to second distribution, and it's number 2 that we're looking for. So it's the normal CDF. You can either scroll down there or you can just type in number 2, enter. And mine's set up so, because I've got the new programming system on there, and all I have to do is just put in my lower value, which is 25, enter. My upper value for this one here is e to the 99. So you'll find your EE button there on the little comma. So EE, and then I'll just go 99, enter. My mean value is 25.3, and then my upper value, my standard deviation is 0.4. Alright, then I'll paste that, enter, and that's what it will probably look like on your calculator. Alright, so, and that tells me my area is in fact going to be 0.7734. Now we always go to 4 decimal places, because when we convert that to a percentage, it will be 77.34%. Alright, so the way you write this out in your piece in your work, so that's equal to, so you're saying it's approximately equal to 0.77, can't write, 0.77 0.34. Okay, so we can say that's 77.34% chance that a nail that you pick from the box is going to be greater than 25 millimetres. Right, so what's the chances? Right, we'll do part B. What are the chances or the probability that's greater than 25 but less than 26? So this is how you'll write into your calculator, and this is how you also put it into your calculator as well if you don't have the new system. So you'll put in 25, 26, 25.3 and 0.4. Alright, so I'll go back to my calculator. Now, because I've just done something like that, I can just go Shift Enter. It'll bring the same thing back up for me. Alright, so it'll look exactly the same as yours then. So we've got 25. I can change that to 26. Not 29, 26. Alright, and then looking at the next bit, so I just have to delete that value there. Alright, the rest of it's the same, isn't it? Alright, so even Shift Enter is easy when you're doing that. Go Enter, and that gives me an answer of 73.33%. Alright, so going back to that, so approximately equal to, because it's not equal to, 0.777, no, it wasn't 77, it was 7333. Alright, so 0.7333, which is approximately 73.33%. Alright, so it's pretty easy to actually do that sort of question. I might just extend that for you. If we want to do a question where what's a probability that our nail is less than 25 millimeters. Alright, so in this case, the same process, normal CDF. Right, and you're guaranteed to get one of these questions in your exam, also in your test. Now, because we don't have a bottom limit, then what we're going to do is we're going to put minus e to the 99. Okay, so when you're going through this video, you might want to watch this section again if you're having trouble, just to make sure you get it right. 25.3. So this is not changing, is it, at all? So again, I could go to my calculator. I could do second function enter, but I might just go through and do it the other way. So here we go to second function distribution. You come down to number 2. Now my lower value is going to be minus, so I've got to use this minus down here. So minus, and then I press E to the 99. Okay, that really sort of making it negative infinity, by the way. My upper value is going to be 25. And everything else is the same, so I just have to paste that in and it works it out. So that's 22.66%. Alright, so that's approximately equal to 0.2266, which is 22.66%. Now, keeping in mind, our value up here was 77.36%. And then it's that value there. Those are complementary events, by the way, and so therefore that's going to add up to 100% of our sample. All right, so simple as pretty well. It's as simple as that. It's pretty easy to do. All right, keeping in mind you've got your formula there, so you have to put your lower limit first, put your upper limit next. All right, then you got your mean value here, goes in there. And then you have your standard deviation going in the next bit for that particular function. So, these are really important questions to get the idea of doing. Keeping in mind, they allow us to work out the areas bound by things that don't necessarily fit nicely on the regions now. Okay, remember before we had nice regions? Alright, so if we're working z-scores out, we know that these z-scores don't lie on the lines anymore. Okay, so we can go midway between these sections. That's it. I hope you have success with that. If you have any questions, make sure you catch me in class.